Hi, I'm Michael, and we're going to take a journey into Miss Shirley's class and see what experiments they're working on.
Word, egg, and air, right?
Okay, did you boil them eggs?
So you're going to find out.
They look like they've been boiled, but they ain't got no sugar.
All right, the next thing you need to do, if you have goggles, clear off your table. Clear everything except for something to write with and a sheet of paper. We're going to be using water and we're going to be using eggs. You don't want that on your stuff. Strike the match. And you're going to stick it in the flask. You're going to have the hard-boiled egg. As soon as you put the match inside your flask, you want to stick the egg at the top. Is everybody clear what you need to do? So designate one person to be in charge of the egg and another person to strike the match.
Let's try to do it over.
You gotta rewatch it. We gotta do this.
I'm going to hold it.
Fire.
Stick both in. Stick the egg on top, quickly. Who's going to strike?
You got the egg.
Wait, I'll put it this way.
On top.
Maybe you should have did it the other way.
No, this way.
I should have let it burn longer.
So you should have your paper so that you can watch what's going on.
How's everybody breaking it so right?
Mine ain't busted.
Mine ain't busted.
So if yours has
Are you
had a
stuck?
quick reaction, make sure you observe some of the other answers to those three questions. Let me close the ball and see if that helps.
It ain't going in. Oh, get out.
Alright, so everybody should have their paper out answering our questions, right?
That's my paper.
Okay, back up.
Act like you're ready.
Record Mark.
You have to wear your eyes. You can put all of that in your observations. And you can put...
Do you guys like science?
No. Yes.
Like, what do you like about it?
The experience.
Experiments.
The experiments.
What reactions did you have when the eggs did what it did?
I was surprised. I didn't think that was going to happen.
So make sure you have the answer to all three questions. We're going to come around to each table and go through each question.
I was surprised too.
Oh, how about you?
Obviously, the egg went down.
Oh.
Yeah.
What did you think was gonna happen?
So, I thought that it was gonna explode or something. I personally didn't. I didn't know what was gonna happen.
Alright, so Quest, what was your answer for number one?
To create more smoke and flames.
So what do you mean by more smoke and flames? Why is that necessary, do you think, for this demonstration? Because remember, the whole topic overall is air pressure.
Because as the smoke came up, the egg was going down. I guess.
Okay, so for this demonstration.
I said for the pressure to be created so the egg would be sucked in.
Okay. So Sierra, did you have the exact same answer or you have something different?
It was the best of the same.
Okay. So Mark, can you tell us? So Josh, why did you need the match and the sheet of paper for this demo?
To create nitrogen.
The match and the paper.
Yeah. Why do you think that was necessary for this
To
demonstration?
prevent more smoke inside the more heat.
Stephanie, one more time, can you tell me what are the three factors that affect air pressure?
Water? No, air molecules? Oh, no, vapor, water vapor?
So water vapor.
Oxygen.
No, you're right. Keep going.
Temperature?
Temperature and altitude. Which of those factors did you just influence? Temperature. How did you influence the temperature?
Causing heat from the matches.
So when you lit that match or you struck the match, that allowed heat to be present. What do you think that did for the air pressure? How does heat change the air pressure? This can be for anybody. This doesn't just have to be Louise.
It's
Or
like
Josh.
lower air pressure.
Okay, so say that one more time a little bit louder.
Lower air pressure?
So how is it lowering the air pressure? So let's go back to our reference earlier. We were talking about the mountains versus the beach. So what's the temperature in the mountains?
Cold.
It's colder. What about the air pressure?
It's more.
Which one did we say? What did Janet talk about? Because Janet was the one that answered that before. So, what do we know about the air pressure in the mountains?
It has higher
It's lower in the mountains. So, if we're talking about the mountains now, we're also adding what factor in? Altitude. So now as we're talking about the air pressure at the beach, what's the temperature usually at the beach?
85.
Which is, in comparison to the mountains, is going to be what? The temperature at the beach in comparison to the mountains is what?
It's hotter.
It's hotter, it's going to be warmer. So what does that mean about the air pressure?
It's higher.
It's higher.
Higher.
So air pressure is going to be higher. What about the temperature?
It's gonna be lower.
So temperature was higher, air pressure was higher. What about the altitude at the beach?
Higher.
lower.
It's lower.
It's lower. Lower.
Lower.
Okay, so when you're talking about gravity, gravity involves what?
Gravity involves something being
Magnetic pull.
pulled down due to magnetic.
So we keep talking about a pull, but is it possible there was also a push?
Yeah, because
Oh, that's what the air pressure is. So now that we've reevaluated what air pressure is, do we think the air pressure is greater on the inside of the bottle or on the outside?
I think it's something.
mine was on the inside because it didn't buzz.
It was greater on the outside regardless if it did bust or not. It wasn't actually supposed to. If yours did not, then yours did exactly what should have happened. So the air pressure is greater on the outside. That's what's causing the push that's going to create the vacuum that's pulling or sucking the egg inside. Does everybody get that?
Yeah. Yeah. Why do you think we need to use the matching paper instead of?
Because the matching paper, when you put it inside, it makes more heat, it attracts more heat and more pressure.
Awesome. What did you observe happening as the matching piece of paper was placed in the flash being stuck an egg?
The egg was slowly sinking in.
You have chairs and stuff pulled out.
That water look nasty.
So Class, put that chair back over
No, that's all the chemicals in
at
there.
your table.
That water, do
So
it.
Class, I heard you. Thank you.
So what's the...
I just want to Josh, what the heck?
I spill it?
Yes.
It's right here.
Alright.
Alright.
So
Wanted
you
to run
go
over.
down
Go
there.
me.
Oh, I didn't mean to. I'm sorry.
Yeah, right. You went whoops. What's that?
Keep your hands to yourself. Stick it in there. Be careful because it is filled to the top. Remember, we don't have any paper towels in here. If you have to clean up, you have to go to the bathroom and grab a paper towel.
What do we do?
Put the water inside the jar. The whole
Put the jar in the container. So now you got to come fill the water back up.
You said, she said put the jar, so that meant
Put new water in.
She said it 3 times.
Y'all went like it's a surprise.
All right, so make sure we're listening and looking for the other people that are ready. You're going to take your index card. You're going to set your index card on top of your jar. So you're going to give some light taps around in the circle to your index card. You can even say your magic words if you need to. So what are some of our magic words we can use? So whatever you think it's going to be. So you can tap if you want to. You're just going to slightly tap around the surface.
Do you tap the actual paper?
You're actually tapping the index card. So just like what Sierra's doing right now. So that's good. Y'all can add magic words if you want to. You don't want to smash it, but you just want to tap. An edge on each side of the index card. So I'll slide mine over just a little bit. So you should be able to see a little bit of the index card on all sides. Then you're going to invert the jar. What do you think is going to happen?
Flip it over.
It's not gonna follow.
It's gonna fall like this while you give us a bucket.
Oh my God.
I know it was.
So only if you have the magic words and the
I'm
magic
waiting.
touch.
I'm scared.
So the question is, who's going to be the person to do it?
Okay.
Wait.
Remove your hand from the bottle.
I got it. So good job.
My paper still
Don't get it touched. Trust me.
Oh, I'll let you.
Got it, y'all. I got this for y'all.
If you do it at an angle, watch this. You will see it leak.
Nice.
Once again, if you do it at an angle, you'll see it leak. But if it's directly inverted, it should not leak.
There you go.
There we go.
We got
Here you
it.
go, Mark.
So that was that.
How am I gonna let it go? Don't put her on weight.
What do you mean?
Yes, what I
No,
tell
when
you.
touch the table.
Why you
that's
do
what
that
makes it
stuff?
work
You're trying to make it
fine.
spill out.
She's just showing you if you tilt it. What'll
Yeah, if
happen.
you
So that's why I was
Oh.
up and not touching the table.
Yes, I was good.
It's fine.
That's only because you tapped
do
into it.
I'm gonna add this in.
it, Mark.
So what do we do for this out now?
Now hold on to it.
Damn.
It's coming
You
out.
do have 2 questions to answer. Stick to the jar.
What?
Same problem, but you gotta do Webster method.
So why do you think that happens?
The pressure.
So what about the pressure? What's
going
different here? What were those 3
You
factors?
find the standard quarter. Instead of upper quarter, you do conventional, like if it's 3.4,
Temperature was 1.
it stays at 3.
There's no water
But
vapor
if
here
it's
though.
3.7,
So water vapor was the other one.
The height above sea level.
So the height above sea level or the altitude. So now we're gonna try this with hot water. And what I'm gonna do,
No, what? I just dumped it.
I'm gonna use red food coloring for the hot water.
Oh, I wanted to do hot water too.
You just want me to dump it?
No, you just flip it back. I'm gonna use blue food coloring for the cold water. I want you to make a prediction of what do you think is gonna happen if I invert both together.
This in the cold gonna stay down.
If that's what you think is gonna happen, write that down.
You should do this with biology.
Not the same thing.
It look like food.
So do you think it's gonna change anything if I put this index card back
Can you
on
put a
this
fresh
one?
on there? And then make these. Make these first.
And I can do what you all did to make sure my water was at the top. Take this beaker of water and add more water to it. Nope. All right, so if I invert, do you think anything different is gonna happen? Just because I added food coloring.
Yeah.
So, you wanna try it?
No.
I'll try it.
So is there a difference? This time I tried to do it with the index card this way. Is there a difference if I did it this way?
Yes. Yes.
What's the
because it
difference?
Sucks it in.
So what do you think is different about my index card?
The shape.
My index card is already bent. So that's something that you have to be careful about when you were using it. Some of you didn't have that issue. So I'm gonna add some more water because I did spill some.
All right. And I'll be over in a minute.
So are we good now? Does everybody approve? Because you said it was up in the air before. So just in case, I'm gonna borrow their container. Then we have a bucket to clean it, right? So no real difference just because I added food color, right? So you probably have to come closer to see. All I'm doing is stacking the hot water on top, the cold water on top of the hot water. When I remove the index card, what do you think is gonna happen?
Maybe they're gonna mix in.
How so?
I don't know. Pressure.
Okay.
It's gonna be so the cold
So-
water gonna go down.
Make sure you remember this observation.
I knew it.
Yep.
Never mind.
That's my fault. The card got
It turned
stuck.
purple.
But what do you see happening?
They mixed in together.
Cold
How
takes
so?
over the hot water.
What do you mean by the cold water takes over the hot water? Where was the cold water? At the top. So what did happen to the cold water then?
It made purple.
Well, when red and blue mix, they do make purple, but what happened to the cold water?
It went down. It sank.
It sunk. Why?
Cause cold go down.
Hot air rises and what is
Cold air.
cold air sinks. So when we were talking about those those fronts, this is what's happening. This is what happens in the air. So I'll clean your table since I made your table wet.
Thank you.
So make sure you.
Go what? So what did you want students to learn from these labs?
Well, these are common everyday activities that the students may have seen or done before in elementary and middle school, but just to connect the concept of air pressure and the factors of air pressure. So there's more than one thing that can alter the air pressure. So we're just trying different demos to see if the students can make the connections between which factors are being influenced at that specific demo level.
How do you think these labs are effective?
Well, one, it gets the students thinking when you have the questions to follow up with it, but they get to make the observations. They don't have to just read what's in the book and say, this is what the book said, so I believe it to be true. They get to make those observations and connections for themselves. So they get to do what scientists do.
Perfect.